Day 73, faults. When magma in the asthenosphere moves in a convection current, it creates forces on the plates in the lithosphere above. Remember that we have the crust on the outside surface of the Earth, and that crust is broken up into sections called plates. And below the crust we have the mantle, and the mantle heats up, and the material is flexible enough, like Play-Doh or silly putty, that it can flow in a current. And so the hot mantle rises, and as it cools, it's going to sink back down and make a circular pattern called a convection current. So as these currents happen in the deep mantle, in the asthenosphere, the top part of the current will push on the individual plates, the sections of the crust, and cause them to move around. There are three types of forces then when we have this kind of movement. Compressional forces, that's when things push together on opposite sides, squeezing. Inside this word we have the word press, so things are pressing together. And then we have tension forces. That is when you pull apart from opposite sides, a stretching force. When you have tension, things are pulled tight, like tight ropes, the tension in a rope. The third kind is a shearing force. That's when we have forces applied in opposite directions. A shearing force is when we have two pieces of plates that are sliding next to each other. They're not necessarily pushing against each other or pulling apart. They are just sliding across next to each other. With those three, we have all sorts of actions going on in the crust. Faults. We have different kinds of boundaries between the plates that are pushed together, and they are called faults. One type of fault is a divergent boundary. At a divergent boundary, the plates are moving away from each other because of tension forces pulling apart. And the type of fault that we get here is called a normal fault. To help you remember the different names, we have the term divergent is when things split apart, and these are I words with the I in the middle of the words there. Hopefully maybe that will help you remember diverging is splitting apart. And here are some pictures of that happening. We have the fault here as the dark line and the plates being pulled apart. And here's another way they can slide away from each other, making a sloping fault here. The faults do not have to be straight up and down. The second kind of fault is called a transform boundary. At a transform boundary, the plates are moving along each other because of a shearing force. And the fancy name for this kind of a fault is a strike-slip fault. And to help you remember, transform is when they slide past. We have S words, S here, sliding, and transform. It's kind of silly sounding, but hey, we're trying to figure out any way to remember these things. Transform boundaries look like this, where this section of plate might be moving to the north, and right next to it we have plates moving to the south. That is what's happening in California at the San Andreas Fault. The part that's closest to the ocean is sliding, I believe it's to the south, and on the west side, or on the other side, it's going to the north. Then we have a third kind of fault called a convergent boundary. At a convergent boundary, the plates are moving towards each other because of compressional forces. The two plates are pressing against each other. Sometimes, at a convergent boundary, one plate travels under the other plate. This is called subduction. One plate is actually going underneath the other, like a submarine would be going under the water. So subduction zones, submarines going underneath, same kind of a prefix. The fancy name for a fault here is a reverse fault that occurs at a convergent boundary. To help you remember convergent and coming together, we have the C words down here at the bottom. Converge, come together, pressing together. And they look like this. In this case, we have the right-hand plate being pushed underneath, so that would be a subduction zone. And here we have another type of diagram to help explain the same thing. Folds. Sometimes the rock layers do not break and make a fault. Rather, they fold, and folds appear as wave-like structures. 3 types of folds. First one is called an anticline. An anticline is an upward curve in the rock layers. It goes up in the middle and then back down. A syncline is when it sinks in the middle. Goes down and then back up. Syncline, sinking in the middle. And then a monocline, where it only goes up on one side, it doesn't come back down. Mono referring to one.